Naming of hydrocarbon. Hydrocarbon. Carbon in group 4. It have a specialty. This specialty is it can form into many shapes. It can form into many shapes and with many different elements. That's the specialty. And these bonds are always very stable. Carbon. When carbon bond with carbon in a single bond, this we call saturated hydrocarbon. Saturated. Student, do not confuse this word saturate with another word that we learned earlier. As water you put out too many spoons of sugar into water and the water gets saturated. I'm talking about not of that saturation in that content. Saturated hydrocarbon means single bond hydrocarbon. Do not get confused. And these single bonds are freely rotatable. Double bond hydrocarbon is called unsaturated hydrocarbon. Unsaturated hydrocarbon. And these structures are rigid. You cannot rotate. As on triple bond, which have 3 bonds, and they also call unsaturated hydrocarbon, also cannot be rotated. So student, take one word. Those saturated hydrocarbon is single bond. Unsaturated hydrocarbon is called double bond and triple bond. Now let's talk more about this hydrocarbon naming. We're listing from 1 to 10 of this naming rule. The stem name means the backbone of hydrocarbon compound. Backbone like a fish have a backbone, and on this hydrocarbon chain have a backbone, and this backbone made of C. And you also have a suffix that are going to talk following. Let's start. If you have 1C, you call meth. 2C, eth. 3C, pro. 4C, bute. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. 10, dex. And student, some of them you may already like familiar, like 5, pen, penny. 8, oct, octopus. 10, decimal. Certain of them you know, but on the first 1, 2, 3, and 4, you might have to put some effort to learn. And now let's start on this single bond. Now I'm going to start on single bond. Single bond of this saturated hydrocarbon, the suffix is ane. ane. So one carbon is called meth. Methane. Methane. 2C, ethane. Ethane. 3C, propane. Propane. Now let's look onto the general formula. CnH2n plus 2. What does that mean? That means on each C, you're going to have 2H, as you demonstrate on the example. Each 1C, you will always have 2H. And what's the plus 2? Plus 2 means you have 1 on the front, you have 1 on the front for the beginning, you have 1 at the back in the end. That's what it means. As in this example, methane, ethane, propane, butane, pentane, hexane, heptane, octane. Now we're going to talk about the double bond. Alkane, and this is called alkene, E-N-E. When you see E-N-E, this is a double bond hydrocarbon, as in ethene, E-N-E, ethene. Propene, propene, 3C. 4C, butene, butene. Student, you see the structure. When you are start to require to pay notice on the structure. Each hydrocarbon, the C always will have 4 bonds. Remember this rule. It will help you to draw hydrocarbon. As if you draw a structure you want to check, are you correct? You just can't. The C have 4 bonds. As in this example. C have 1, 2, 3, 4. This is correct. Look at this C. 1, 2, 3, 4. This is correct. Now let's look onto the propene. 1, 2, 3, 4. Correct. Look at this. 1, 2, 3, 4. Correct. So when you drawing structure, some student will very hesitating. Does it need one more H or one less H? You can't. The C always have 4 bonds, and you can count to make sure to check. Alkene, the formula. When it comes to alkene, the formula are more simple. CnH2n. That means 1C require 2H. Now look, we see. Okay, 2C, you need 4H, ethene. 3C, 6H. Butene, pentene, hexene, heptene. Now let's look onto the structural formula, the middle part. Student, we are going to learn a word called isomer. What's meant by isomer? Isomer means you have the same molecular formula but of different arrangement. Repeat, same molecular formula but different structural arrangement. Now I show you. Let's look onto the example. On the period 1, 2, 3, they only have a single structure. So now we look further. So when you come to the 4th, you got 2 different structures. So you see you have the same molecular formula with 2 different structures. The structural naming, you see one is called 1-butene, another called 2-butene. Why? That is the position. The position is this way. 1, 2, 3, 4. It is on position 1. So you call 1-butene. The second one. 1, 2, 3, 4. Position 2. You call 2-butene. So you based on the position. Student, there is no left counting or right counting. We are not based on left or right, but rather we based on whichever give me the smallest number. So if I count the other way, if I count the wrong way, like if I count 1, 2, 3, 4, this becomes 3-butene. That is wrong because it didn't give me the smallest number. So we base on whichever giving the smallest number to count position. Now let's look at another example under the same rule. This is another isomer. One molecular formula with two different structures, double bond here and this double bond here. And based on the same positioning, this is called 1-pentene. The second one called 2-pentene. Now go to the 6. So now you have another 3 isomer. These 3 isomer, you have 1 hexene, 2 hexene, and 3 hexene. And 7 have even more isomer with different positioning 1, 2, and 3. So we have to focus the word isomer. Be very careful. Isomer means you have the same molecular formula but can have a different arrangement. As on the top one, C4H8, you can have the double bond here, or you can have the double bond in the middle. As C5H8, you can have a triple bond on the here, or you can have the triple bond in the middle. So that's called the isomer. And now when you come to triple bond, YNE, the naming rule very similar. Triple bond, YNE, unsaturated hydrocarbon. 2C, ethyl. 3C, propyl. 4C, butyl. Now let's start exercise. What is the name of it? A. This is a single bond. AC single bond. Obtain. B. What's the name? 5C. Double bond. End with ENE. 2-pentene. Position 2. C. What's the name? 7C. Double bond. Position 2. 2-heptene. Last one, 1C. Methane. Now let's do one more exercise. So now this is how you name. And now let's look onto the structure. What is the formula for A? But 4. C4H double bond is double 8. B. Octane. It is a single bond. So C and H2N plus 2 rule. C8H16 plus 2. C. 3-octene. 8. C8H16. Hex. Double bond again. C6H12. Now we learned the formula. Now we do the structure. The first one, propane. 3C. Single bond. Second one, butene. 4C. Double bond at position 2. Now you count the C. Does the C have 4 bonds, especially the double bond part? Let's look. C have 1, 2, 3, 4. So this is correct. Look at this. 1, 2, 3, 4. This is correct. Double check the other. Just make sure. 1, 2, 3, 4. Correct. How about the final one? 1, 2, 3, 4. So they're all correct. That's the way you check the double bond. Hexane, single bond. 3-octene, 8, position 3 double bond. Now octane, be careful. Let's count. It should require 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is AC. Position 3. 1, 2, 3. This 3 should be the position of double bond. And now make sure you have 4 bonds on the double bond. 1, 2, 3, 4. Correct. Look onto the other side of double bond. 1, 2, 3, 4. And now this is correct. So student, this is the way how you draw the molecular structure, the structure formula, the structure name and formula.